Hello and welcome to today's Saratech Enablement Series. My name is Sarah Utsugi and I'm the Marketing Coordinator at Saratech, and I'll be your host today. Presenting today, we have Mark Anderson, who's a Saratech Senior Applications Engineer, and he'll be talking to you about feature-based manufacturing. All right, hi Mark, thanks for joining us. How are you doing today?
Good, Sarah, how are you?
I'm doing well, thank you. Can you tell us a little bit about yourself and what you do at Saratech?
Sure. As Sarah pointed out, I'm a Senior Applications Engineer with Saratech. I specialize in all CAM products. I have roughly 25 years in industry using multiple CAM platforms, the majority of which is in NX.
Nice. Well, it sounds like you're the expert, and we're excited to hear what you share with us today. Why don't you go ahead and share your agenda and take it away?
Okay, thank you, Sarah. So today we're going to be discussing more in-depth feature-based manufacturing. Last year I did a feature-based manufacturing CES that just went through the basic out-of-the-box functionality. So the first bullet point is we're going to go over that same overview so that the people who didn't get to see that understand what feature-based manufacturing is, what do you have out of the box with NX, and what functionality is needed with the feature-based manufacturing knowledge author license. The second, we're going to go into customizing the out-of-the-box operations using the machining knowledge editor, and this does require an authoring license. We're going to discuss what conditions are, what rules are, and what makes feature-based manufacturing tick. We're going to go through two different methods of teaching operations. We're going to go through the inside of NX user interface. Then we're going to also use the machining knowledge editor. Differentiating between the two, one is used internally as you're going, one can be used independently of NX. We're also going to discuss what role does CAD and PMI play within feature-based manufacturing. And then we're going to go through a couple of success stories. So the overview of feature-based manufacturing, NX will interrogate the part to identify all the features. It does this in two ways. One, if it does have an NX history tree, it directly looks at that tree and it will provide operations and feature types consistent with the type of operation used in the CAD environment. If it does not have that and it's a dumb solid, then it interrogates the part and it looks for any 2.5D feature that it can apply the feature-based manufacturing to. The tooling is derived from the tool database within NX. So once you create a tool, you save it to the database. It can then be pulled by the feature-based machining. So once the feature has an operation type selected, NX then looks at the tool library to combine the features and the operations to a tool and tool type that will best complete the feature. So it's a three-tiered approach. NX first interrogates the model, finds the features. Second approach is it goes to the tool data library and it pulls a tool that can be paired with that operation type to create that feature. So let's go right into a demo. So this first plate here is just a stripper plate for a die. It's a simple 2.5D feature part. There's a couple pieces that need to be done before feature-based manufacturing will be able to find the features and it will be able to program. It has to understand what is the part and what is the blank so that it can look at volumetrics of what needs to be done to apply the correct operation types. So we'll just choose a simple bounding block. Now we go directly into find features. This is where NX interrogates the model, finds the features, and these are the types of features that it's able to find. We can segregate areas and feature types if we would like to. I just broad spectrum ask NX to analyze the part, interrogate it, find the features for me. You can see that the status bar at the bottom is recognizing the features and it's going to populate them in this section here. So you see it's found the slots, it's found holes, it's found a lot of different feature types in here. So once we hit OK to these, they populate. What I'm going to do is I'm going to select them all, right click, and I'm going to group those features. What this does is it just groups them into like attributes so that these 4 holes are independent features, but it will group them together to where when I'm programming, I just have to select a feature type instead of independent holes. And those will populate down here in the geometry groups. So now you see we have feature groups, not just features. I select them again, I right click, and I create feature process. So now what this is going to do is it's going to run out to this machining knowledge database, and it's going to apply these types of operations. and tooling that are adequate to use to cut that feature. When I hit OK, it's taking the features that it's found, pairing them with tooling and operations, and then it's going to populate this in my operation navigator. The features, the operations it creates never come generated. You have to regenerate, and that's specific for a reason, so that you can see any types of issues that you may have. So it's gave me a tool path for just this top surface here. Now, with a few different selections, it would find all these features and it would program them all together. This particular exercise is just to show what NX does and what it's finding out of the box with NX. So where does this apply to you? Why would you use this without the authoring license to be able to manipulate? Well, this has done a lot for us. If I was manually programming this part, one of the first things I would have to do is come here, create geometry, come into hole making, hole boss geometry, and I would have to start identifying what are my liked features. All of that was done. This particular feature, I've just clicked 6 times, when I can do 3 button clicks and I can get all of my features to where now I can just go through and start programming and selecting these. So it's automatically out of the box going to give you a much more efficient process to get to where you start programming. The majority of 2.5D features will come with a correct toolpath. The only thing that it may not give you is tooling that you have in your tool crib. It pulled it straight out of the library. So this particular tool may not exist in your library. So what we would have to do is we would have to create our own tool that we do have, or we could go in here to the operation. We could edit the tool, change it to the characteristics of the one we do have, or we could just retrieve a different tool from the library and then just regenerate. So the majority of the time with parts like this, NX will give you an accurate toolpath that works just fine. The only thing that you would have to do with a non-author licensee would be to either create tooling that is in your tool crib or adhere to the tooling that NX gives you. So now, back in here. So now that was just out of the box NX. That was just what do I get with any package of NX CAM. So the benefits of using that are going to be, it will streamline your process up to the point that you need to program. So all of your clerical type stuff before you program, creating geometries, creating cut areas, creating trims, all of that is taken care of for you. So now we get into more depth, more of the efficiencies of the machining knowledge editor and feature-based manufacturing if we have the author license to be able to modify those. So now let's get into this demonstration. So with this part here, there are certain criteria that are within the machining knowledge database that are called just root conditions. So when NX is looking for a strategy to cut this pocket, it has to match the radius of the tool to the radius of the feature, because there's no logic within NX to say up to a certain corner radius, use a certain diameter of tool. Anything more than that, use a different diameter tool. So if it can't figure out the logic, if it just cannot figure out what it's going to, how it's going to do it. So in this, we have a couple features that I've already created. We're just going to find them so we can see that NX has the logic within it to find these types of features. So they are feature types within NX. We go through the same process of grouping the features. Now we have our groups down here. Now, when I go to program these, when I go to create the feature processes, when I tell NX to go ahead and interrogate that, find the features, find the operation, find the tool, it comes against a condition that says I cannot produce a tool path. I can't find a tool that's this corner radius. And if we went to that information window that just popped up, it would say that it requires a tool of X diameter less than or equal to. There's no tool in the database that hits that criteria. So how do we go ahead and create operations for this? How do we teach them into the system so that they can repeat? So I have another part here where I have operations already created. So I have my feature group. I've done everything that I initially did, where I found the feature, I interrogated the part. I'll group the features. So now I go in and I do programming. So I program this to where this is the methodology that I would always like to use when it runs up against this type of feature. I want to make sure that I stress this. You do not have to understand coding. You don't have to understand TCL. You don't have to understand even the conditions or the rules to be able to efficiently use this. All I have to do is right click, object, teach operation set. It brings in everything that this toolpath has to it. Once I start selecting on here is all my non-cutting moves, my step overs, my cut levels. So this is all the internal inner workings of the adaptive milling process. Now, if I go over here, this is the internal interface, the internal dialogue. All of these are set directly to this part. So if I come in here and I look, it says that my bottom roughness is 250. So it either has no designation on it or it has a 250 roughness finish on it. So if I were to have this exact same feature, but it was a 125 finish, this strategy would not be called. So I want you to make sure that you understand that when you teach these features, it's very specific to that feature. Now I'll go into it a little bit later on how do I open things up so that it understands that pockets of this nature with different variants can still use this strategy. So let's go through on completing this teaching. So once I've went through this and I've validated that, yes, this is what I want, I teach the rule to the system. So now if I want to come back through here, I'll do the same with this one. If I come in here and I move these to the unused items, and I reprocess this, you'll see there's a few things different. Finding the features, it processes correctly. I'm going to group the features. This process never changes. But now when I go to create feature process, you're going to see a difference. Now when I come down through here, I have operation sets. These are specifically taught into this. You can do it from the role-based drop-down, or you can just go to operation set based. And this looks directly to the operations that have been taught in by the user. Me personally, I like to use this so that if you run against, so if I do a feature-based manufacturing, interrogate the part, and there are other features that doesn't have knowledge for it that have been picked up, if I use the operation set dropdown, then it's not going to program those because there's no operation set that's associated. So I like to use rule-based and have everything checked because it first goes to operation sets, then it comes up and picks up from the machining knowledge database. So if I have the operation sets checked and I hit OK to this, you're going to see that it's going to give me the exact thing that I want. Everything that I told it to put in there, it's going to put in there. But there's a big difference here. Oh, it doubled me up because I have some more info. So there's some things that you have to take into consideration when you're using this. So when I told this to program that into the feature-based manufacturing, I used operations that have caveats to them. So if I tried to tell this adaptive milling operation, and I taught it into the system for automation, but I used physical characteristics off of this part to teach it, like using a trim off of the part, that will not work for another part because it's looking for this entity. So the correct way to do that would be to add a trim area, come in here and create geometry, create a trim area, and set this trim area. What that'll do is when you teach this to the system, it'll just be a blank taught trim boundary, but you'll see it there and you'll know that you have to go in and manually select a trim. So if I were to process this just as it gave me, it would say that it has issues. but all we would have to do is give it a trim. Give it a, so it's trying to go through this. So you have to think about how you're going to process in data into the machining knowledge database so that when you're using it on a different part other than the master part that it's been taught off of, that it can either automatically pick up that data, like using a first floor option for tool axis, that would just select the floor instead of being a specific entity on the taught part. So you really want to get away from using individual entities on the part to teach into the system. You have to think about it in a circular way of how is that going to affect my selections on the other part. So you can put in trim areas, and even if they're not needed, it'll just be a blank setting. So you want to think about how this is actually going to be processed to the secondary parts, and not just the individual parts you're working on. So this was showing customization through the interface, the Teach Operations Set interface. The next demonstration that I'm going to do is I'm going to walk you through the inner workings of the machining knowledge editor. Now, what is the machining knowledge editor? Everything that you saw in that dialogue that I was showing you, like the 250 finish, corner radiuses, things of that nature, that is all written in this logic here. So just like it had the plus symbols for your non-cutting moves, for your step over, your cut levels, all of that is a listing inside of this database. So let's take a look at that. So you have the tabs down here. So right now we're in recognition. The dialogue I showed you previous within NX, that is strictly machining knowledge editor operation set teaching. The machining knowledge editor also has recognition rules. So how does it recognize these parametric features? The different information on what is it looking for when it says that I found a step 2 hole, what is the criteria for a step 2 hole? So we're working inside of this machining knowledge here. So inside the machining knowledge, we have our different options here, turning wire, EDM, milling, operation sets. So the operation set that we taught in there, it has the same exact conditions that were in that dialogue, except they're in text format. So you can see how operation across voids follows. So these are settings. You can set different information in there. Tool description, 3/8 end mill, tool diameter. We can put logic in here to say 0.125 to 0.375. And then that will give us a diameter selection variable that the system can pick. Flute length, we can tell it that for this particular tool, we only have 1 inch of flute. So we want to go 75% of that. Then we can also put in logic to say if this feature, the depth grows in the pocket, then we need to have a longer tool. And this is how we're setting all of the criteria for how does it process the tool path, how does it pick the tools, and what conditions is it allowed to do. All of these conditions here, operation boundary approximation false, collision checking true. This is saying that the operation is going to come to you with collision checking on. If I put false here, then the dialogue inside of NX, when we would look at the collision detection dialog, it would be unchecked. So I mainly unchecked this one. So that's why you're seeing that here. But this is what you're doing. You're turning off and on pieces of that dialog or setting information in the dialog. So you can do feature-based manufacturing authoring in 2 ways. What I recommend for customers who are getting into this is teach your operation sets. If you come against a feature that has a unique cut pattern and tooling, then teach it. And then if you come against another one, teach it. The system, it can handle as many features as you want to teach it. It's not until you get into an area where you understand this language well that you can have one feature and make it parametric. Parametric meaning that this feature that I'm seeing here, well, what happens if this feature gets wider, longer, or deeper? Or what if the corner radii change, the fillet and the corner radii? We could make one logic And then we could change all of those conditions and those rules to give it information to say, if it goes deeper, then pick a tool with the tool length criteria that fits that. We could even give it logic to say, use the shorter tool first. When I get down to a specific depth with a cut level depth of X, use another tool that's just longer to start from there and go to there. So we can build as much logic as we want in here. Feature teaching is exactly that. You're teaching all the specifics into this feature, into the knowledge database with that tooling. And if it runs against the same exact criteria, it will reprogram it exactly the same way. If you have feature types that are similar, but some of the attributes change, then you have to put that logic into your teaching. And you can do it in two ways. You can do it through the feature-based manufacturing knowledge editor, or we can do it within the teaching. Oh, I'm not sure what I did here. Oh, there we go. We can do it through the dialogue. Yeah, it's not allowing me, but anyway, the dialogue that we just seen, you can do it through there. You can change those parameters and it will update the machining knowledge database. So what is the role of CAD and PMI within feature-based manufacturing? Because this is very, very important. We don't want to be controlling this data in manufacturing. This is not a manufacturing data control area. We want to apply processes for features that our CAD department gives us. So if we go through and we teach these attributes to the system, that's fine because we're teaching a direct feature from the CAD department. But we don't want to alter that in any way because we're not going off the design intent. So what we can do is we can have CAD give us specifics. We can have them start applying surface finishing to things. We can have, say, a 10 millimeter H7 hole, which is modeled nominal to 10 millimeter. We could also have 10 millimeter holes all throughout the part that are just 10 millimeter holes. And feature-based manufacturing will be able to distinguish between the two because of either the H7 tolerance or a surface finish or a color or any other type of attribute that changes it from the other. I just ran into this with a customer just the other day where their CAD department was designing everything nominal, not by tolerance, not bilateral. So when he tried to do feature-based manufacturing, there was nothing to distinguish anything from a 10 millimeter dowel hole to a 10 millimeter slip fit to just a 10 millimeter through hole. So without there being some type of characteristic that's different, feature-based manufacturing is not going to be able to pick them up from one another. So one rule of thumb is as many attributes as we can get on the feature, the better off we are because we'll be able to apply them directly to feature-based manufacturing. So now with PMI, what does PMI stand for? Product Manufacturing Information. So when they start applying different PMIs on it, dimensioning, GD&T, we can utilize every single one of those attributes to drive logic through to the part. So if the part has distinct attributes that identify the feature, it's easier to develop specific machining practices for it. And what I just explained, a lot of times you get into features that look identical, have identical attributes, but may need a cleaner finish or maybe a sized hole or may have geometric tolerancing and dimensioning to it that we have to drive a different cutting strategy to. And if we have PMI data on the part, then we can easily distinguish between the two and set parameters and operations specific to that. Now, one thing I did want to mention too is the use of feature-based manufacturing out of the box without the authoring license is still a very valid tool. Me personally, when I am doing contract programming for Saratech, I don't care if I'm programming a fan blade for an air or a 360 Airbus or something. I always start with feature-based manufacturing because it derives all of my geometries for me, all of my holes, all of my everything that I need. I would have to manually do before it creates for me. So at least I have 50% of my upfront work done for me. So, and I very rarely teach processes into the knowledge editor for contract work because it's singular, but I still use feature-based manufacturing for the upfront part. So even if you don't want to use the create feature processes, it's still a very good idea to start with feature-based manufacturing especially when you're doing 2.5D work, because it will find those features for you and it will at least give you something to use. Maybe not 50%, maybe it's only 25% of your operation will be completed for you. So anything that we can do to get you to streamline your programming would be benefit. So one of the different areas that I've worked previously was I worked for a different VAR, and one of our customers was a stamping facility. The stamping facility was a major player for the big three. They created torque converters and clutches. The majority of all of their work, I would say 95% of their work was all 2.5D features. They were either pockets for dies, draw rings, all the 3-dimensional features were inserts. So my particular job was to automate a progressive die shoe. These are 4 foot wide, 8 foot long, 2 foot thick, 4140 with thousands of holes, die locations, and things like that. And in a short period of time of maybe 3 months to 6 months, we were able to program all of those features into the system the exact way that they manually programmed them, to where they simply had a right-click find feature, right-click group feature, right-click create feature process. And it took away the ability for them to have dedicated high-level programmers for that particular job, to where they could put lower-leveled interns and junior programmers on that type of thing. And then they had all the attention ability for them to do all of the 3-dimensional work. So the time reduction alone paid for itself very, very quickly. But what it ended up doing is it ended up opening the shop up to be able to do a multitude more worth of work, because the only downtime now was machine changeover time. Instead of, we're not ready for that program, this program is going to take us 40 hours to complete. Now they're able to use this to be able to judge those program times down to the hours. So we were able to reduce their programming time by 75%. It was a very good job, and it was not a hard thing to do. What we did is we helped the company to get the library started and get them a running version. And then what we did is they would send us features. We would not only program them, but we would also walk them through how to do that. So it was small hand holding. We gave them a product up front. We held their hand to get them going, and then they took off from there. So it's a very good tool to use, and it will make your job a lot easier if you implement the full gamut of the feature-based manufacturing with the machining knowledge editor authoring license. But if you don't have that level or that capability, it is still very efficient to use this up front to get all of those benefits. So notable takeaways, as I said, even though out-of-box capabilities, or even the out-of-box capabilities would reduce your programming time, it creates a very efficient way to identify, organize, and in most cases, provide efficient toolpath. As I said, 2 ways to do it out of the box with no alteration. 1 is adhere to the tooling that NX picked, or 2, change the tooling once the operation is created, regenerate it with a tool that you do have, send it to the library, and then the next time that tool may be used. I can't guarantee that tool would be used, but you do have the ability to go in and remove the out-of-the-box tools and put just your library tools, and then it will force the feature-based manufacturing to choose out of those. So utilizing the machining knowledge author license, it allows the companies to program a feature one time, prove the process and tooling, and consistently reuse that data on future features in an automated and efficient way. So once this database is built or it's being built, we put this on a central location, a network location, and then we point all the users to it so they use the same data. Generally, until the company gets to where all users are very knowledgeable of the system and confident in what they're putting in, we recommend that there's only one architect. So one person takes on the task of teaching features, and then once everybody gets up to speed to it, then you can have everybody teach into it. But that way it will save things from not corrupting or messing the database up until that feature's been taught. There's a guaranteed immediate benefit of utilizing feature-based manufacturing. There's a potential of 80% increase in programming output with confidence and reliability. One of the things that this does is, if you say you did have a part like I was describing, a 4 foot wide, 8 foot long, 2 foot thick piece of 4140 that was going to run for, say, 20 hours, So once you have these processes in that you're fully confident in, you can put in a few checks and balances, like maybe some tool touch-offs to make sure that you still have a tool after it's ran. And then on Friday at 5 o'clock, you put this part on, you load the tools and you go home. You simulate it in NX, and then you can be confident that it's going to run exactly as you say it is. Now, I understand that there's problems with doing that and things can come up and things can happen, but we have 100% very well done this to where very long run times, we would just implement a few laser touch cycles in between tools so that when it got done, it would come down, check the tool. If it was still there, it would process the next tool. And if it wasn't there, it would call the operator and tell him he needed to come change a tool. So you can get very reliable. So at us at Saratech, we have a lot of experience in assisting or even just creating these libraries for customers. So what we do is you give us a feature type, a part that has the majority of your features on it. We teach those processes with your operation types. And then another way to do it is you buy a block of time from Saratech, say 40 hours. You give us that initial block of features. We do it. You have 20 hours left. Your programmer just sends me a file whenever they want. I add it to a machining knowledge database. I can either go into your network and implement it behind the scenes, or I can give it to you to where you can implement it, and then you have the features in your library. We also teach this. We also do a full training class on how this works, how to use it start to finish, and we do even get into some very aggressive logic with parameterizing features. Sarah, are there any questions?
Yeah, it does look like we have a few questions. The first is, how do I remove a tool saved in my library, specifically a turning tool? How well does this work with turning?
It is fully functional for turning. It uses the same types of logic. And if you're asking on how do I remove a tool from my tool database, that is done within NX. If you come here to your tools, you have edit machining data libraries. No, I don't think tool, no, this is not it. So the library reference is in C drive, program files, Siemens, 19, well, whichever version, mock, resource, library, tool, and if it's ASCII or, and then tool database. So this database here contains your tools. No, I don't want to. Yeah, it's in here. I can give a better. Oh, here it is. Okay. So this is your database right here. So you see this is right here is your NMIL 5 parameter. So you would want to look for the tool. Here is your library tool numbers. If you have a specific tool that you want to remove from that library, say we'll go with drill. So you see these have all these UG references, UG11. So we would go in that database and find the correct name for it and then remove it. So right here we have 1113. This would be that tool. Or no, it's not, but you understand what I mean. So this database, you have to find the specific tool and remove it. This is something, if you're going to remove tools, my recommendation to you is find this file, copy the file before you do anything to it. You got to make sure you delete an entire line by dropping down and not going out. So don't go to the right and try to copy the whole thing. Just drop down one. That way you know you get the whole thing. And yes, it does work for turning the exact same way as it does for milling. You develop these processes and then you teach them.
Thanks. It does look like we have
Yes.
another question. It says, if we buy the author license, how much work is involved in creating our own database?
There isn't. It's as you go. So as you're programming, if I had a part if I go right-click find features, right-click group features, right-click create feature process, and then there's empty features out there, you just teach the feature to the system. So that would be teaching the system. Then you would teach your operation set into the system. Now that feature itself is now taught. But say this, like I said, this gets wider, longer, or deeper. That is where you go in and you just have to find those particular lines in the interface and alter them to be X width, X or X depth. So but you don't even have to do that. You can do individual feature by feature by feature by feature, as long as those features repeat. But if those feature types don't repeat, but the feature entities do repeat, then you just have to apply that logic within the dialog. So it's not that it's simple, but it's not difficult once you are educated in what you're actually doing. So if you are going to take this on yourself, there is a free starter kit from Siemens that is called Feature-Based Manufacturing Starter Kit. And what this will do is it will open your eyes to the processes. It will give you a mock demonstration, and but it will not go into the machining knowledge database. It won't go into the editor, but it will walk through a process somewhat similar to this to get you to kind of understand what you're doing. And then it will explain what the attributes are within the conditions and the rules. I do recommend that you do get some type of training because it can unravel. And when I say unravel, I mean, if you teach in bad logic and then you try to do something parametric to where that logic is controlling a lot of other different logics, if you break that logic, it'll break the other logics. So it can become a ball of mess if you just shoot from your hip and try to figure it out as you go. It's something that you may do a couple times because you're going to find that what I taught last corrupted my database. But if you go through a 3-day training course, or if you go through a 6-hour training course, or if you go through some type of training to where you have somebody skilled go walk over your shoulder and say, well, these are the reasons why you're doing this, and this is what the output is going to be, then you adhere to a specific pathway and it becomes very easy.
Great. Looks like we have a few more questions coming in. It says, is this available to all users to review, or do you need the author tool to see it?
No, the out-of-the-box functionality where I was showing you right-click find features, right-click group features, right-click create feature process, that is available to all CAM users, even to a CAM Foundation license, it's available. The only time you have to have the authoring license is when you want to change that logic or teach your own operations into the system.
Great. Another question, it says, without the author license, can NX still output appropriate tool paths after finding features, or is that an addition with the authoring license?
No, that is included. The only difference is the tools that are going to be used are tools from this library. So if you may not have these tools. So if the system determines that a 1/4-inch end mill is the best suited to cut this, but that end mill has an odd taper or a reduced shank or some specifics to it that you don't have in your tool crib, then you either have to do one of two things. You either have to adhere, purchase that tool, build it exactly like NX told you to, or just create your own tool and then regenerate the operation. So the process that I do is when it gets a tool that I do not have access to, I will just go into the operation. I will change that tool to one that I do have and then just regenerate. This adaptive is a very long toolpath. So, and then just regenerate. So the out-of-the-box functionality, you do not have to have the authoring license to be able to utilize it up to the point of just changing the tool and then regenerating. But if you want to keep that process and teach it to the system is when you need the license.
Great. I think we have time for 2 more questions. So the first one is, I only see group options for turning. How could you expand the turning to more complex parts that rely on fixture, clamps, and tooling avoidances?
I would have to need more information for that question. So to try for you, how do you incorporate fixturing? And I assume what you're meaning is, how do I make sure I don't hit the fixturing, or how do I make sure that I cut around the fixturing, or things like that? And that part is not determined from feature-based manufacturing. So if we're talking about check surfacing, then we would do that in this, which is not a part of feature-based manufacturing for your fixturing. Now, if you're talking about something to do with the fixturing that toolpath is generated from, we would have to put the appropriate geometries before it, whether that's a cut area, a trim, whatever attributes we would need to do to associate that fixturing, we would have to implement into the operation. Sarah, I think the best thing for that particular customer's question would be for him to email me direct. There's a lot of meat and potatoes to that question.
Okay, great. So yeah, Dustin, go ahead and shoot Mark an email. I'll include Mark's email address in a follow-up email. Also, if you want to take it down now, it's manderson@saratech.com. We do have one last question. It says, can the tools I create be added to the library and saved for later use?
Yes, absolutely. So when we go in here, this is my process. I never create a tool before I start programming. And that is more of a, I would say, comfortability with NX. We never have to create tools before we process. Before, in other CAM systems, we literally had to say, these are the tools I have. This is the way I'm going to process it. This operation has to be first, second, third, fourth. With NX, you can just pick something. Just start somewhere, and then you go over to program order view and just switch it around. So I never create tools first. I always create my operation, then I come in here and I'll retrieve from library. Let's say I already have a tool. All right, so I've got an operation from feature-based manufacturing. I said, this isn't the tool I want. I'm going to choose this tool, and we're going to make that tool a 1/2 inch and mill with all these parameters. You come to this library panel. Each one of these are called a panel. You open it up, and then you say export tool to library. Once I hit export to library, it's going to say target class. You want to be specific. So if it's a non-indexable solid end mill, then choose it. If it's indexable, choose it. So once I choose this, it's going to ask me my template attributes for my holding system. Now this would be if I wanted to use a holder template. So I'm just going to assign a, whatever it be, 40 taper holder. That's for pre-built templates. So I just choose none here. When I hit OK, you're going to get a dialog that says this tool has been created and sent to the English tool library. No tool part file is saved. There's a lot of people getting confused with this, and they feel that it's not been saved. The parametric tool has 100% been saved to that dialog. There's no tool part file saved with it, is what it's saying. So there's two things that you can do when you save a tool. So if I have a holder, everything, if I had a step file of my tool, say I was building a face mill and I got my body from Sanovic, the holder from Sanovic, the nut from Sanovic, all of my insert screws and my insert, and I literally built an assembly of this tool. Well, we can build a tool from that. And when we go in here to export tool to library, it would say, where is my holder? Where is my junction point? What is my cutting surface? Where is my junction point on the spindle? And it would physically write the actual model of the tool. So don't get confused by it saying no part file is saved. It's still 100% still there. It's saved. So now if we went in here to the database and looked for that 1/4 inch tool, oh, wrong one. So I have that 1/4 inch tool here. So it will save it to the library. Just don't be confused with no part file is saved. That just means that there's no physical models that are attributed to that part. But yes, every time you save a tool, every time you create a tool within NX, this is just across the board, not tooling, not feature-based manufacturing, not anything. This is standard programming with NX. If you do something twice, create something to not have to do it twice. If you create a tool twice, create the tool, save it to the library. You create an operation twice, create a template, teach it to the system so that you're pulling reusable data. If we go through here and we're doing the same things over and over and over again, it's very inefficient. The rule of thumb with NX is if you do something twice, create something. If I'm trying to drill and tap a hole, that's a perfect example. If I just have a single hole in this part that takes 3 tools and I don't create a geometry, I'm picking that hole 3 times. If I just come up here and say create geometry, hole making, hole, select the hole, now I have a geometry group. All I have to do is when I say create an operation, we'll go into center drilling. Now all I do is I select the feature instead of multiple times having to come out and select the hole. So that applies to everything though. It applies to operations, it applies to tooling. If you're consistently doing something more than one time, there is a way within NX to save that and repeat the use very easily.
Great. I think that's all the time we have for questions today. So Mark, will you go back to the presentation and click to that next slide?
Sure.
Great. So if you're ready to take it to the next level, Saratech offers much more than just software. We have a wide variety of options for training and services, just like Mark had mentioned earlier, and we also sell 3D printers. So if you have any questions about that, or if you have any additional questions, you can email us at marketing@saratech.com. Thank you so much for attending. Thank you, Mark, for your time, and have a great day.
You're welcome. Everybody have a great day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.